What's a rate?
A measurement over time.
Exactly. A measurement, something, some measurement over some time, right? A distance is how far, right? How far. Rate is how far the distance did you cover over a certain amount of time. Miles per hour, feet per second, whatever you're measuring, okay? So essentially what we're trying to do is we're trying to figure out how rates are related, or using that they're related to find other things, okay? So today, everything we see as a rate is going to be, there's going to be a lot of rates, okay? So before we get into today's, example one just talks about how do we write the rate, right? A, B, C, and D, there's all rates, but they're in words. How do we put those in symbols? Because we're going to be using a lot of symbols today, okay? So rate is a quantity over time, distance over time, okay, with respect to time. Time's always on the bottom, okay? So write the following rates mathematically. Marty is growing at a rate of 3 inches per year, okay? So how do we write that mathematically? So not as a sentence, but as a symbols, using symbols or abbreviations or anything like that. Okay. So what's the important things there? Not all of those words are important. What are the most important things there? Or what is an important thing in 1A? 3 inches per year. Yeah, that's the rate, isn't it? That's the rate. So we have 3, right? Is it positive 3 or negative 3? Because it's growing, right? Okay. So this is going to be the newer part. The newer part is how we're going to write it. So everything is with respect to time, right? So we're going to write everything like this. Every rate, we're going to symbolize like that. D, the quantity, over dt. dt means time, over time. What is the quantity for this guy? Inches, right? So we're going to write di, right? di over dt, because it's 3 inches per year. Time is always t, dt. I could label it, there's different things I could label it. Dg over dt, because it's growing. There's different ways you could label it, but that's essentially d quantity over time, okay? Okay, so my stock portfolio is losing 5 cents per day. So what is the actual rate? 5 cents per day, right? 5 cents per day. So we could say 5 cents per day, or you can say $0.05 per day. Either one is okay. Is it a positive 5 or is it a negative 5? Negative 5, good. So now we got to know how to label it. So how do we label d what over d what? Well, is there a time here? Day, right? So dt is going to go on the bottom. What is the quantity? Cents, right? Well, it's part of a portfolio. So in this case, I would put dp. The portfolio is going down. Okay? I know it's in cents, but what's going down? The portfolio. Okay? Okay. C, the radius of a circle gets larger by 4 feet each hour. Okay, so 4 feet per hour. So it's over time. So we're going to put dt on the bottom. What's getting bigger, though? What's getting bigger? Radius. So that's going to go dr over dt. Okay. The temperature outside is dropping by 5 degrees Fahrenheit per minute. So 5 degrees Fahrenheit per minute. That part you guys have done before, rates. The left side of the equal sign is the new part, labeling it. So how would we label that? D what over D what? So what would we label the bottom? dt, okay. What is dropping by 5 degrees? Temperature, right? Well, in science and in math, we call temperature capital T. So capital T and lowercase t aren't the same thing. Lowercase t usually means time. Capital T means temperature. So we could have 2 t's as long as one's capitalized and one's lowercase. Okay. What's wrong with that though? It should be negative. Yeah, it needs to be negative. -5 because it's dropping. Okay. That's the first thing we're going to do. Anytime we have a related rates problem, they're going to give us a rate. We have to label it. Okay. The second thing we're going to have to do is find derivatives. Find derivatives. Okay, so the first thing I need to do is find the derivative of a with respect to time. Now, these guys are all respect to time. 1a, b, c, and d are all respect to time. How do I know that? By looking at them, how are all of them written with respect to time? Yes, how do we know that though? On here, you're right. They're all being divided by time. What shows that over here? Which part of this shows that? What you just said? dt, yeah, dt. So that's what I mean by with respect to time. Over time. Okay, so when we find derivatives, these guys have got to be over dt. Okay? All right, so let's start with the first guy. What's the derivative of 2a, or a squared? With respect to time. What did we just find the derivative of? What did we just find the derivative of? It's an easier question than I think you guys are thinking. Remember when we did this stuff here? So what did we just find the derivative of? No. What did we just find the derivative of? It's a lot easier than you're thinking. The derivative of this was this, right? So what did we find the derivative of there? X. X, right? And then what did we find the derivative of here? Y. What did we have to do when we found the derivative of y? Anything other than x. Add the little tag, right? So let's go back here. What did we find the derivative of? A. Anything that's not a t, we have to write d over dt. Needs that tag. The only things that don't need that tag are lowercase t. And that's not a lowercase t, that's a lowercase a. Okay? So now plus, how do we find the derivative of b squared? 2b what did we just find the derivative of? B over dt. C squared? The derivative is 2c dc over dt. And then we'd isolate one of them, right? Well, we're not going to do that because we've done that already. I just want to kind of go over this part here, okay? They're all with respect to time. That's what that means. They all have a dt. The only ones that don't have a dt are the ones that have a t. I don't see a t anywhere, so they all need a tag, okay? So let's go to A now. What's the derivative of capital A? Capital A is a variable, right? So what's the derivative of A? 1, right? But it needs a tag, right? So the tag is going to be dA over dt. Okay. This is where it gets a little tricky. What's the derivative of, how do I find the derivative of this guy here? How do I find the derivative of this guy here? Yeah. A lot of people see this and they think, oh, use quotient or use product rule, right? Why not? Why do I not use product rule for the yellow? No. Pi is a number. Pi is a number. Pi is not a variable. Even though we use a letter for pi, a Greek letter for pi, it's a number. It's not a variable. So we treat pi like a number. Treat it like it said, like if it said 4r squared, 10r squared, right? Don't treat it like a variable. So exactly, we're going to move 2 pi, move 2 to the front, take away a power, and then give it a tag. The first thing we did in this chapter was called implicit differentiation. That's what this is, implicit differentiation. Anytime you need a tag, to give it a tag, it's called implicit differentiation. Why are we giving it tags? Because there are rates. Everything is with respect to time. Any rates are with respect to time. That's why we give it tags. So everything we do today is going to need that tag, something over dt. Okay? Okay, so here are the steps. They don't make much sense right now because we haven't done a problem, but once we do a problem, they'll make sense. Okay? So the steps. We always do step 1, 2, and 3. Okay? Step 1, what are you given? Write down everything you're given. Everything they've given you, write it down. First step. Second step, what are you trying to find? What is the question asking? It's important to always know what you have and what you need. Because if you don't know what you have, you might already have it unless you actually write it down. So write down what you have. Write down what you need. That's where you're going, right? Now what you're going to do is you're going to write an equation that relates, here's the relates, the variables, right? So depending on which equations you're given and what you're being asked to find, you're going to come up with an equation. It's not hard. The equations are pretty simple. Okay, they're equations you've seen before. Step 4, we're not going to do today. Step 4 means make another equation if you need to. We're not going to worry about step 4 today. We'll do that tomorrow. 5, differentiate. What we just did, find the derivative with respect to time. Plug in what we know to figure out what we need to solve. Okay, like I said, seems like a lot, but it's not. Once you see this, it's pretty harmless. Okay, other things to know. If something's increasing, the rate is positive. If something is decreasing, the rate is negative. Sometimes we need to use product rule. All differentiation will be implicit, means tags. Anything that's not a t, lowercase t, gets a tag. If asked, don't forget about units. So sometimes I'll ask you about units. Don't forget about those to label at the end. And if something isn't changing, if something doesn't change, so don't plug in numbers into the original equations for things that are constant. So if something is constant, it's not changing, the rate is always going to be 0, right? If something is not moving or changing, right? If someone's standing still, you're not changing distance, right? Over time. So that's just 0. That's what that's saying. Okay, so that, make sure you read the question to help you out. Okay, so here we go. Let's look at example number 3. First example. Number 3. So we're going to highlight, underline, circle, whatever you need to do, important things. First thing we're going to do is read the question. Second thing we're going to do is write down everything that we do know. Okay? A rectangle has a length of 1 inch and a width of 6 inches. Whose sides, though, are changing? Okay, so the sides are 1 and 6 right now, but they're changing. They're not always going to be 1 and 6. The length is increasing, getting wider, getting longer. The width is also increasing. Okay, the length by 4 inches per second. The width is growing at 8 inches per second. What is the rate of change of the area? Okay, so the first thing is we got to write down what we know. I always start with a picture because a picture, trust me, helps, especially when you're starting to do this. There we go. Okay, rectangle. Okay. The horizontal sides I'm going to call X. Vertical sides I'm going to call Y. What do we know about that rectangle? What's one thing that we know about the rectangle? So the length is 1 inch. I'm going to call that X. So X is 1 inch. X is 1 inch. Good. What else do we know about that rectangle? Width is 6 inches. I called that Y. Good. Okay. We also know the other things. What else do we know about this rectangle? Okay, so the length is increasing, all right? Positive 4. How do we write that? How do we write that? Doesn't that look like one of these guys? How do we write that? The length is increasing by 4 inches per second.
dt equals 8 inches per second.
So you're close. You said dl over dt.
Yeah.
I don't see an L anywhere. That's going to be a problem. Why don't I see an L anywhere? Do you guys, anywhere in here, do you guys see an L anywhere? Why not? Because I'm using X and Y. So instead of dl and dt, what can we use?
X.
There you go, X, right? So dx dt, good. dx dt. Equals what? What is the rate? 4 inches per second. 4 inches per second. Good. I know one more thing. What else do I know? Good. So how would I write that? dy over dt, good, equals 8 inches per second. Good. That's everything I know, right? Is there anything else in there that I know that I haven't written down? I don't see anything. I think we wrote everything. That's the first step. This is the first step. Second step, what do I need to know? What is the question asking me? Rate of change of the area, right? How do I write that? I don't know that answer, so it's going to be a question mark. But how do I write the left side of the equation? Because isn't it a rate? It's a rate, right? Rate of change of the area. How do I write that? No. Imagine letter C. 1C said the area of a circle gets larger by. How would that change? So imagine this guy said area. How would the problem have changed? There you go. It would be just dA over dt. Yeah. For area, we use capital A. Capital A for area. That's the only difference. That's what I need to find. That's step 2. Step 3, find an equation that relates everything. So I know x, I know y. I know rates of change for x and y, and I know area. Or I need to know area. What's an equation that would relate all of those variables? The equation of what? That would relate. What's an equation that would relate? How can I say this without giving the answer? What's an equation that would relate everything that I have with what I need? So what do I need? Area. Do I know area? No. What do I have? What do I have? Okay, which are what? No. Length and width. So what you guys have told me is I need area and I have length and width. Do those things go together at all? There's a formula, right? That you guys have used forever. Area equals what? Length times width. Now in my problem, I didn't use L and W. So area is A equals X length times Y. They're always going to be common equations. It's not going to be hard equations. They're going to be very common equations that you guys have used many times. Formulas. Sometimes they're called formulas, right? Length times width is a formula. Okay? That was step 3. Step 4, we're not going to worry about. We're going to go to step 5. Step 5 says differentiate. Find the derivative of that guy with respect to time. So what's the derivative of A with respect to time? dA over dt. Good. dA over dt. Good. Equals. How do I find the derivative of x times y? Product rule, right? Product rule says the first times the derivative of the second. What's the derivative of y? Exactly. dy over dt plus the second times the derivative of the first, dx dt. There's the derivative. Go back to the steps. Step 6, plug in and solve. I know some of these things. dA over dt, I don't know. But I know what x is, right? What is x? 1. Do I know what dy dt is? 8. Do I know what y is? 6. Do I know what dx dt is? Multiply, multiply, and I get 32. I get dA over dt equals 32. My answer is a rate. How do I label that? No, it's going to be over seconds. You're right, over seconds. What does 32 represent? There you go. It represents an area, right? Top is an area. So it's going to be inches squared. Inches squared. If it was a length, inches per second would work. If it's a width, inches per second would work. But the top is area. Every problem you do is going to look like that. Related rates problems are the easiest to spot because it asks you about rates. There's always some shape involved, and it's always increasing or decreasing, and what's the rate of change. They're the easiest ones to spot because of this. And guess what? Every related rates problem is going to be done the same way. We're going to do number 4 the exact same way we just did. It's a different shape, but it's done the same way. Okay? It's done the same way. Okay, so you got a right triangle. Has legs 33 and 44, and those sides are changing. Okay, so I'm going to draw a right triangle. First thing I always do is draw a picture. Takes you about 5 seconds to do, and it helps with the process. Right triangle. The legs are the two sides that make up the right triangle. So one is 33. So anything going horizontal, I call X. Anything going vertical, I call Y. Just to make sure I don't change. So one of them is 33. One of them is 44. Right? And we know about right triangles, those sides are interchangeable. So could Y be 33 and X be 44? Yeah. The long side, the hypotenuse, I'm going to call Z. Since I'm using X and Y's, I'll just use Z. I'm not going to use H. Okay. Okay, so I know X is 33. My X is 33. My Y is 44. Inches. Okay, that's the first sentence. From the very first sentence, I got all of that. Okay, second sentence, the short leg for me is X, right? Now, if you flipped them, the short leg for you would be Y. Okay, so like I said, they're interchangeable. So the short leg is increasing by 4 inches per second. So that's dx over dt. Increasing by 4 inches per second. The long leg is actually shrinking by 10 inches per second. So that means it's going to be negative 10. If it's shrinking, it's losing size, so negative. What is the rate of change of the hypotenuse? dz over dt equals what? So I know the length of one side. I know the length of another side. I don't know the length of the hypotenuse. Or do I? Do I know what z is equal to? I could find it out, right? So even though they didn't tell me this, I can use my brain and figure out, hey, I can figure out what z is going to be, right? Isn't it a squared plus b squared equals c squared? So 33 squared plus 44 squared equals c squared. Okay. Anytime they want you to calculate numbers like this, they're going to let you use a calculator because I'm not going to waste your time calculating. 33 squared, 44 squared. So 1,089 plus 1,936 equals z squared. When I add those two guys up, I get 3,025. Take the square root of z, and it's 55. I could have done it without, because it's a 3, 4, 5 right triangle. If I divide them all by 11, they become 3, 4, and 5. 3, 4, 5 right triangles, very common right triangle. So I could have done that without, but still the easiest way. So z equals 55 inches. That's all the stuff that I know and that I don't know. Is there an equation that relates all of these things? And it will help me find the rate of change of the hypotenuse. Think of a right triangle. What is the formula or equation that goes with right triangles the most? What is the one that's associated with right triangles the most? So there's two of them that are associated with right triangles. Area of a right triangle. Area of a right triangle, or any triangle really. Area is 1/2 base times height. And the other one is a squared plus b squared equals c squared. Which one of those will help us get the answer? Area? Will area of this triangle help us get the answer? They don't ask us about area. There's nothing in there that says anything about area, right? So I'm thinking that one's, we're not going to use that one. The second one is Pythagorean theorem. It helps us solve for a missing side, right? And it asks us about the hypotenuse. Hypotenuse is always c squared, c. So this is the guy we're going to use. This is the guy we're going to use, okay? Except in mine, I didn't call it A, B, and C. In mine, I called it X, Y, and Z. Okay? That was step 3. Step 4, derivative. 2x dx dt, 2y dy dt, 2z dz dt. Plug in. So 2 times x times dx dt. 2 times y dy dt equals 2 times z dz dt. I don't know dz dt. That's what I'm trying to figure out. Well, in math, if you have everything except 1, you can solve for it. And that's what it looks like I have. I have everything except dz dt. So I'm going to solve for it. So let's see. 2 times 33 times 4 is 264. 2 times 44 is 88. Times negative 10 is negative 880. 2 times 55 is 110. dz dt. Solve for dz dt. Well, first thing I'm going to do is I'm going to add these two guys up. I get negative 616. How do I get dz dt by itself? Divide. Divide by 110. If it's a calculator question, we can get a decimal. Sometimes these are not calculator questions, so you're just going to reduce it. Okay? So if I was going to reduce it, I'd divide them both by 2. You'd get negative 308 over 55. If you don't have a calculator, as far as you can go. If you do have a calculator, you can actually divide those. It's going to be 5 point something. So just depending on the question. Let's see, 308 divided by 55, 5.6. There you go. Last thing. What units go with it? What units go with that number? So what would go on top? Inches, good, inches. It's not an area. Hypotenuse is just a length. Didn't say area anywhere. So it's just going to be inches. It's not going to be inches squared. And then what was the time they used? Seconds. Seconds. There you go. Like I said, either one of these guys. If you can't use a calculator, just reduce and go as far as you can. If you can use a calculator, divide them. Okay. So literally on number 3 and number 4, we did the same exact thing. Now, are they the same shape? No. So we had to use a different formula, but we're doing the same thing every time. So that's the nice thing about these guys. Sometimes when you see a word problem, you're like, but the hardest part about a word problem is not knowing what to do. That's the nice thing about these guys, about related rates. You always got steps. Do this first, do that second, do that third, do that fourth, those kind of things, right? Okay. All right, so we're going to start number 5. We're not going to finish number 5, but we'll start number 5. Number 5 is a question off of a past FRQ. I took it off the FRQ and put it on the notes because it was a good question. I used it for a few years and then I put it on the notes. What I do sometimes, I don't use the same FRQs all the time. So sometimes when an FRQ, I've used it enough, I put it on the notes. So that's what I did. So number 5 is a FRQ question I used to use, not anymore, but it's a good question. That's why I put it on there. Okay? It's an application question. It doesn't talk about a triangle. It talks about a ladder. It talks about a wall. Things like that. Okay? Okay, so a 25-foot ladder is leaning up against a vertical wall. First thing I'm going to do is draw a picture of what that looks like. So, walls always stands up straight. Vertical wall means it stands up straight. The ladder leans up against it, right? Ladder, you lean up against a wall. And then this is the ground here. Right? So the ladder is the, let me highlight this. The ladder is the yellow. The vertical is up and down. The ground is on the side. Okay. The bottom of the ladder is being pulled away at a rate of 3 feet per second. How fast is the top of the ladder moving when the bottom is 15 feet away from the wall? Okay, so let me label this. Since I used, it makes a right triangle, right? When you put a ladder against the wall, that makes a right triangle. So I have X, Y, Z. First thing I need is everything I know. What do I know? What do I know? 25-foot ladder. So what is going to be 25? Z, good. Z, 25 feet. Good. Now we're going. What else do we know? Bottom's 15, right? It says 15 feet from the wall. That's X, right? X is 15 feet. Good. What else do we know?
The rate is 3 feet per second.
So the bottom is being pulled away, right? Pulled away means away. So the bottom is going that way, right? So how do I write that? Dx over dt. Dx over dt, good. Positive 3 or negative 3? Is that 15 going to get bigger or smaller when it's pulled away? Bigger, right? So positive 3 feet, is it feet per second? Good. Do I know why? I don't know why. Can I figure out why? Yeah. So you can use the Pythagorean theorem, or you can do it a quick way. If I divide 15 by 5, what do I get? If I divide 25 by 5, what do I get? It's a 3, 4, 5 right triangle. So if I divide them all by 5, I get 3, 4, 5. So what does that mean y is going to be? 20. If you don't know that, use Pythagorean theorem. Okay? It's okay if you don't know that. It's okay. If you didn't know that, use Pythagorean theorem. You would go 15 squared plus y squared equals 25 squared. Solve for y and you would get the same thing. Y is 20. Let me put that on my list. Okay. What is the question asking? How fast is the top of the ladder moving? So the top of the ladder is right here. If the bottom is being pulled away, the bottom is going in that direction. Which way is the red dot going to go, up or down? Down, right? So we know it's going to be a negative number. How do we write that? We don't know that, right? So that's our X. That's our question mark. How do we write that, though? How do we write that? dy over dt, good. Because this guy is going down, right? How fast is the top of the ladder moving? It's going down. We know it's going down. How do we write that? It's a rate. How fast, right? dy over dt. Good. Okay. I think that's everything that we know and everything that we could figure out and stuff like that. Last thing. We're not going to finish this problem today, but what formula or what equation would we use to solve, to help us figure out dy over dt? Again, we have two formulas that go with triangles. Area of a triangle, Pythagorean theorem. Does it say anything about area? No. So it's going to be a squared plus b squared equals z squared. What's the next thing that we do after that? Have we already done that? So we know the answer, right? 2x dx over dt plus 2y dy over dt, 2z dz over dt. It's the same exact thing we just did. That's why I always use the same letters, because it helps you. Okay, so 2 times x. What is x? 15. What is dx dt? 3, right? 2y. What is y? 20. I don't know dy dt. Z, I know z is 25. What is dz dt? I don't have that on my list. There's an important reason why I don't have it on my list. Why don't I have it on my list? No. Has nothing to do with math. Or a little bit to do with math, but very little to do with math. Why not? Close. What is dz? You're right, it's not changing. It's 0. Why is it constant? Because the ladder is 25 feet, right? Z is not changing, right? Z is not changing, okay? Z, I can't make the ladder bigger or smaller. It's 25 feet, that's it. So that's why it's 0. So that whole side is just going to be 0. 2 times 25 times 0 is just 0. Last thing, solve it. Let's see here. Let's see. We get 90 plus 40 dy dt. I'm going to subtract 90 from both sides. 40 dy dt equals negative 90. Divide by 40. dy over dt equals negative 9 over 4, which is the same thing as negative 2.25. And since it's going to be feet per second. Does it make sense as a negative number? Yes, we said that, right? We said that. It's going to be a negative number. That red dot's going to come down. That red dot has to come down if the bottom is being pulled out. Okay? B and C have different parts of the same question. So we'll do that tomorrow. Okay?